Sample problem 11-02. In both cases, a massless rod is supported by a fulcrum, and a 200 kilogram hanging mass is suspended from the left end of the rod by a cable. A downward force F keeps the rod at rest. The rod in case A is 50 centimeters long, and the rod in case B is 40 centimeters long. Each rod is marked at 10 centimeter intervals. Okay, that's going to be interesting. Will the magnitude of the vertical force be greater than, less than, or equal to for A versus B? So we really want to compute these torques. The rod is massless. Fulcrum is another word for pivot. So we have a pivot point there. And we're basically going to be talking about the torque needed, the force needed to make the torque 0. So for everything, the torque is R perpendicular times F, right, for each force. So in case A, I'm going to call one little interval L. And for case A, life is easy because the line of action for the weight is like that. And therefore, the torque due to gravity is mg times L. And the torque due to force F is F times a distance 3L. And so we need the sum of the forces to be 0 because we have no rotation going on. The weight tends to spin this thing like that, and therefore it's going to be a counterclockwise or positive torque. So it's going to be mgl. And the force, the unknown force, tends to spin the rod the other way, so it's going to come in as a negative. So if 3fl is 0. And we can see from all of that that F is going to be 1/3 the weight. All right, so we want to keep that in mind, that in case A, the force is 1/3 the total weight. So whatever that turns out to be in newtons, but that's not a big deal. Now we're going to clear out the board a little and look at case B. In case B, the line of action is still that vertical line, but now it's going to be this distance that's going to be our important moment arm. So I'm going to draw that triangle over on the side a little bit clearer, or a little bit larger at least. We have a length L. There's our line of action. We want R perpendicular. And there is some angle theta that we aren't given, although I guess maybe we could figure it out, but we certainly aren't given. Notice that it's kind of weird. The rod is longer in case B, but it doesn't actually end up mattering that much because we still have the separations are still 3 and 1, or I guess 10 and 30. Anyway, over here we find that R perpendicular is L cosine of that angle, whatever it is. And therefore the torque due to gravity is mg, and now we have L cos theta. And that seems kind of ominous because we don't have that angle. But if we look over here for the force, then this is going to be, the force is R perpendicular, and notice that this will be the same angle. And therefore for the force, we'd have tau F is going to be F times that distance, which is going to be 3L cos theta, which already sounds a little suspicious, a little ominously related. And then we still have that the sum of the torques has to be 0, so mgl cos theta minus F times 3L cos theta equals 0. And then we can see, oh, I can factor out the L, and I can factor out the cos theta, and I'm left with mg minus 3F equals 0. And then I can divide these guys out, because neither of them are 0. And I'm left with mg minus 3F equals 0, so F equals 1/3 mg, which is interesting because it's the same as case A. And so our correct answer would have been they are the same in both cases. Even though they tilt, the tilt affects the moment arm the same way for both of them, so it doesn't change the final answer.